I'm 104 years old, and nuts are not a snack. They're one of the most sophisticated neurological delivery systems that nature has ever engineered. Most people think of nuts the way they think of chips or crackers, something to grab between meals, something to fill the hand when the hand is restless. They pour a handful into a bowl, eat them without thinking, and move on. And in doing that, they miss almost everything. Because what is happening inside a nut, and what happens inside the brain when that nut arrives, is one of the most layered and precise biochemical conversations in human biology. This is not about snacking. This is about maintenance of the most complex organ in the known universe. Let's start with what most people actually know, which is surface level and incomplete. They know nuts have healthy fats. They've heard omega-3s are good for the brain. Maybe they've read that walnuts look like tiny brains, and someone told them that means something. And at the very outermost layer, yes, that is technically true, but it is like saying a symphony is sound, accurate and almost entirely useless as an explanation. The brain is roughly 60% fat, not metaphorically, structurally. The physical architecture of every neuron, the myelin sheath that wraps around nerve fibers the way insulation wraps around electrical wire, is composed largely of fatty acids. When that insulation degrades, signals slow down, thoughts take longer to form, memory retrieval becomes effortful. The sharpness you associate with youth is not magic. It is, in significant part, the integrity of those fatty sheaths. And those sheaths require a constant supply of the right kinds of fat to maintain themselves. This is where most people stop. They hear healthy fats, they eat a walnut, they feel virtuous. But it goes deeper than that. The specific fat profile inside different nuts does different things inside the brain, and the timing and combination of that delivery matters in ways almost no one talks about. Walnuts are extraordinarily high in alpha-linolenic acid, which is an omega-3 fatty acid that the body can convert, imperfectly but meaningfully, into DHA, which is the dominant structural fat in the cerebral cortex. The cerebral cortex is where conscious thought lives, where language is assembled, where decisions are made and memories are encoded. When DHA levels in the cortex drop, the membranes of neurons become stiffer, less fluid, signals don't propagate as cleanly, synapses don't fire as efficiently. The brain doesn't announce this the way a broken bone announces itself. It just slowly, quietly becomes less of what it was, and most people attribute that to aging. Some of it is reversible with the right inputs. DHA from walnuts is one of those inputs, but here's what most people miss. It is not just about the fat. Inside a single ounce of mixed nuts, which is the portion I eat every afternoon without exception, there's a matrix of compounds that interact with each other and with brain tissue in ways that are not yet fully mapped by science. Vitamin E in its natural tocopherol form, present in almonds particularly, is a fat-soluble antioxidant that embeds itself directly into cell membranes, not floating around in the bloodstream hoping to intercept a free radical. Actually, inside the membrane, protecting it from oxidative degradation in real time. The brain is the highest oxygen-consuming organ in the body. More metabolic activity means more oxidative stress. More oxidative stress means more cellular damage over time, unless something is actively neutralizing it at the membrane level. Vitamin E from almonds does exactly that, and it goes even deeper than that. Magnesium, abundant in cashews and Brazil nuts, plays a role in brain function that is staggering in its scope and almost entirely invisible to most people, because magnesium deficiency doesn't produce dramatic symptoms. It produces subtle ones: slightly worse sleep, slightly higher anxiety, slightly slower cognitive recovery after stress. Magnesium regulates NMDA receptors, which are glutamate receptors central to synaptic plasticity, the mechanism by which the brain physically changes its structure in response to learning and experience. When magnesium is insufficient, those receptors become hyperactive. The brain becomes noisier, more reactive, less able to filter signal from noise. Chronic low magnesium is extraordinarily common, and it quietly degrades the very machinery of learning and memory. A small handful of cashews in the afternoon is a delivery mechanism for the mineral that keeps that machinery properly calibrated. There is also something happening at the level of neurotransmitter precursors that is worth understanding before we go further. Tryptophan, present in almonds and cashews in meaningful quantities, is the direct precursor to serotonin, not a distant relative, the literal raw material from which serotonin is synthesized. And serotonin is not simply a mood molecule. That reduction is one of the most damaging oversimplifications in popular neuroscience. Serotonin modulates memory consolidation, attention regulation, and the sleep architecture through which the brain clears metabolic waste via the lymphatic system every night. When tryptophan is chronically insufficient, the downstream effects are not just emotional, they are cognitive, structural, and long-term. The conversion of tryptophan into serotonin also depends on B vitamins and magnesium, both present in the nut matrix, which means the compounds are not working in isolation. They are working together as cofactors in an integrated biochemical system that the body already knows how to run, provided it receives the raw materials to do so. Now we get to the layer that even people who study nutrition often overlook. The polyphenols. Nuts, particularly pecans, hazelnuts, and walnuts, contain polyphenolic compounds that do something extraordinary. They cross the blood-brain barrier. Most compounds cannot do this. The brain is extraordinarily selective about what it admits, wrapped as it is in the tightest cellular membrane in the body. But certain polyphenols, when they arrive in sufficient concentration and in the right lipid context, meaning accompanied by fat, which nuts provide simultaneously, can enter brain tissue directly and modulate neuroinflammation. Neuroinflammation is the hidden engine of cognitive decline, not the dramatic inflammation you feel in an injured knee. A low-grade, chronic, invisible inflammatory state in the brain that is now understood to be centrally involved in Alzheimer's disease, Parkinson's disease, and the ordinary age-related cognitive erosion that people assume is simply inevitable. Microglia, the immune cells of the brain, when chronically activated, release cytokines that damage neurons. They essentially mistake brain tissue for a threat and begin degrading it. Polyphenols from nuts help regulate microglial activation. They help quiet an immune system that has been trained by decades of modern diet to remain in a state of constant low alarm. This is not supplementation in the conventional sense. This is dietary information being delivered to the brain's own immune cells, telling them to stand down. The practical power of this is enormous, and it operates on a time scale that most people lack the patience to appreciate. There's no dramatic moment where you eat walnuts and feel your brain improve. The mechanism is cumulative and protective. You're not treating a symptom. You are maintaining infrastructure. The analogy I always return to is road maintenance. A road that is properly maintained never gives you the dramatic evidence that it needed maintaining. It simply continues to function. A road that is neglected for 20 years collapses dramatically. The absence of obvious progress is not the absence of real progress. Every afternoon, portion of nuts is maintenance on infrastructure that will matter enormously in 20 years, whether or not it is perceptible today. But the death continues. There's a compound in walnuts called ellagic acid that gut bacteria convert into urolithins. Urolithins have been shown to trigger mitophagy, the selective clearance of damaged mitochondria inside cells, including neurons. Mitochondria are the energy-producing organelles inside every cell, and when they become damaged, they don't simply stop working. They become actively toxic, producing a reactive oxygen species that damage surrounding tissue. A brain with a high proportion of dysfunctional mitochondria is a brain running on compromised power. Urolithins from walnut-derived ellagic acid help the cell perform its own quality control, identifying and clearing out the damaged mitochondria so that new, functional ones can take their place. This is a regenerative process. This is cellular renewal triggered by something as ordinary as a walnut eaten in the afternoon. Connect this now to the deeper principle, which is that the brain does not operate in isolation from the rest of the body's biochemistry, and every dietary decision either maintains or degrades the systemic environment in which the brain operates. Blood sugar dysregulation, for example, the kind produced by high-carbohydrate snacks eaten in the afternoon, creates insulin spikes and crashes that are increasingly understood to affect cognitive function directly. Some researchers now refer to Alzheimer's disease as type 3 diabetes, reflecting the degree to which insulin resistance appears to be implicated in its development. Nuts, eaten in the afternoon when blood sugar tends to naturally dip, produce a response that is the biochemical opposite of that dysregulation. The fat and protein content of nuts slows digestion radically, producing a sustained, gentle glucose release rather than a spike. The brain receives steady fuel instead of a surge followed by a drop. Over years and decades, this consistency of fuel delivery is profoundly protective for neurons that require constant, stable energy to maintain their structure and function. There's also the matter of zinc, present in pumpkin seeds and pine nuts, which participates in over 300 enzymatic reactions in the human body, and is particularly concentrated in the hippocampus, the region of the brain associated with memory formation and spatial navigation. Zinc modulates synaptic transmission in the hippocampus in ways that directly influence the efficiency of memory encoding. When zinc is chronically insufficient, which it is in a significant proportion of older adults, the hippocampus operates below its potential. Memory becomes effortful, not because the memories aren't forming, but because the synaptic machinery for forming them is running on insufficient resources. The practical application of all of this is simpler than the science might suggest. 1 ounce of mixed nuts in the afternoon, not a massive portion, not a therapeutic dose, simply a consistent daily ritual, provides a matrix of fats, minerals, antioxidants, polyphenols, and phytocompounds that collectively address the primary mechanisms of neurological aging. The timing matters. The afternoon timing specifically matters because it corresponds to a natural circadian dip in both energy and blood glucose. Replacing a sugar-based afternoon snack with nuts changes the biochemical trajectory of the entire second half of the day. Steadier energy, more regulated neurotransmitter activity, less inflammatory signaling in the evening hours when the brain consolidates memories during sleep. The memory stays sharp, not because something extraordinary is being done. It stays sharp because the conditions required for sharpness are being maintained consistently over time through something so ordinary that most people walk past it in the grocery store without understanding what they are looking at. Every nut is a sealed package of neurological support, built by a plant that had to store everything necessary to produce an entirely new organism. The concentration of what is inside that package, the fats, the minerals, the antioxidants, the polyphenols, is not accidental. It is the result of evolutionary engineering operating over millions of years. The brain recognizes these compounds because the brain evolved alongside them. They are not foreign to it. They are, in the deepest sense, familiar. Signals the brain knows how to use and has always known how to use because the architecture of a human biology was built in a world where these compounds were present every day. That is the real power, not a supplement, not a pharmaceutical intervention. A return to a biochemical conversation that the brain has been waiting to have every single afternoon for your entire life. And the deeper truth, the one that sits beneath all of this science, is that the brain does not decline because aging is inevitable in the way most people accept that word. The brain declines when the inputs it requires are absent for long enough that the maintenance falls behind the damage. Every person who reaches old age with a sharp mind, a reliable memory, and a clear internal world has, in some way, consciously or not, kept feeding the system what the system needs. The nuts are not magic. They are consistency. They are the daily act of taking seriously the fact that a 100 billion neuron organ requires real materials to remain what it is. Ignore that long enough, and the decline feels like destiny. Honor it, afternoon after afternoon, and what feels like mystery begins to look exactly like what it is, the entirely predictable result of giving the brain what it was built to receive.